All right, so we're going to get started here with the yoga pose. And if you've been in this room earlier today, you've probably seen a lot of really great presentations. David just gave a really great one about imposter syndrome, which I think we're both feeling a little bit right now.
Absolutely.
And he also mentioned some things about confirmation bias, and a quick little story about that. I've got a wife and 2 kids, and they were lucky enough to come along with us on the trip here today. And anytime I go on a work conference, my wife calls it a work vacation. So I always explain, no, we're learning. It's very dedicated. We're spending a lot of time learning new technologies, networking, meeting people. So when we're driving up to the resort yesterday, and we see the palm trees and the beautiful sun, I think the confirmation bias set in, and this is, in fact, a work vacation.
She needs a vacation.
Well, she's at the beach today. So just a little bit about Bryan and myself. Bryan is a software lead at Lockheed Martin. He's been developing software for pretty much his whole life, but over the last 20 years, really, as a lead developer, chief architect of a lot of really cool systems. He is really the driving force, like the conductor and really the engine to drive a lot of our programs forward. And that's where my train analogy runs out of steam. Myself, I'm a DevOps tech lead, which means I'm not good as a developer and I'm not good at operations. But really what I enjoy doing is enabling our developers to be able to do the things they're best at. And for humans, it is being creative. And we're best when we're solving problems. And a problem that we're not very good at solving is doing repetitive tasks over and over. Remembering all of your build instructions, running all of your tests. Yeah. So I take a lot of joy in automating all of those things so that the creative people, especially like Bryan, can do what they're best at and solve those problems.
Yeah, DevOps makes our life better, absolutely.
A little bit more on the personal side, and maybe to highlight again how we are a little bit of opposites. I live in upstate New York, and that means that I enjoy winter. And I have 2 small humans as roommates, and like I mentioned, they're at the beach today. They say that you should try everything at least once in life just to see what it's like. I've done the science on this next one. You guys don't get hit by a car. It's not so much fun. And I'm primarily a carnivore.
For myself, I live in Los Angeles, where we experience 0 months of winter each year. I live near a beach, Venice Beach, unlike the Great Lakes Beach. I have 2 roommates, wife and dog. And I've been hit by 0 cars, much better experience. Herbivore, so no meat. And what we can both agree on is beer and coffee.
Yep, I think that's what makes us such great friends.
That's right.
All right, so why are you guys here? Primarily to see us make fools of ourselves. Bryan called me up a few months ago and said, hey, why don't you come to Southern California and go to a conference? So I said, okay. And then a couple weeks later, I called Bryan and said, hey, why don't we present at that conference?
And I said, okay.
He said, okay. So a few of the technologies we used for Yoga Pose. Node.js, I don't think they'd really let us in the door if you're not using Node.
To show your card.
React, which now has hooks, which we'll go into a little bit. Hooks are awesome. TensorFlow, one of the fun toys that we don't get to play with a whole lot in our day job, so a good excuse to build this toy and to have some fun with new text. Some pose estimation that happens in real time in the browser, and then some of the deployment things that I find pretty interesting.
So React, yes, the one with hooks. Really great if new tech in 16.8, I'm sure a lot of you have seen those, and we were like, great, we're moving over to hooks, we're going to use hooks for this whole thing. So it said, look how easy useState is. Started using useState, and then you're like, well, wait a minute, I need something when the component mounts. And so then I'm off using useEffect, and then I want to share some global states, and now I'm using useContext. And then like I have this mutable thing that I want to keep track of over all these renders, so now I'm into useRef. And then you want to use the setInterval command, and when you plug that in while you're using hooks, nothing works. So then you're off using a custom hook called useInterval. But overall, really great tech. And useInterval is super interesting if you have a chance to go out. Dan wrote a blog post on it, on how it can be used instead of setInterval.
Yeah, it's really interesting how the underlying hook technology allows you to take the ones that React has published and use them, but also extend them in ways that you can be creative about and find new uses for, like the one that Dan published for handling intervals. TensorFlow. How many people have heard of TensorFlow? Several. How many have used it before? Fewer. All right. So TensorFlow JS is pretty cool. It's one of the many implementations of TensorFlow. It allows you to train and deploy models in the browser or in a node environment. I think it makes machine learning easy. We work with a lot of data scientists, and they're really big nerds. And they make machine learning actually easy. Like the things that they do is really impressive, and it makes our life as more front-end and our application developers easy to take what they've done and really just implement it. So it was fun for us to jump into TensorFlow and actually start playing with some of the models, creating our own and seeing how we can work with them. Another great thing about TensorFlow is the docs. Like there's a handful of tools that I think have really amazing docs. Docker is one of them. TensorFlow had really great docs. Bootstrap is amazing for that stuff. So when a tool has really great docs, I think it really makes things easier when you're trying to adopt it or at least understand how to use it.
Yeah, so specifically out of TensorFlow, there's a model called PoseNet. And what it's used for is determining pose estimation in real time. So you'll feed it either a video or an image, and what that model will give back to you are 17 different body parts. It'll show you in XY where somebody's eyes are, where the nose is, shoulders. And so you can take those, take that pose then and basically run your algorithm against those 17 different body parts to do whatever you want. In our case, we're going to be scoring some yoga poses. But the pretty cool thing about PoseNet, and really like where we get to see the power of the browser and how far we've come, is that it runs completely in the browser. So there isn't any data being sent back to some external server. That TensorFlow, that neural network, that pose estimation is all running exclusively within your browser. And then just use a convolutional neural net to actually return those pose. And basically, there's a neural network under the hood that, in basic terms, is looking at these images, determining that, oh, a human is in this image. These are the parts of that human, and then mapping that to XY coordinates that you can then use.
So out of the box, PoseNet ships with a handful of models. The first model is a mobile-enabled model. It's quite a bit smaller. It's kind of tuned for performance, but it gives a lot less accuracy when coming up with the key point positions and confidence in each of those. There's a beefier one called ResNet 50, which I really wanted to work, and it really crushed the processor to the point where we're getting like 10 to 15 frames a second, which sucks. So we couldn't go with that one. So we used some of the tuning parameters with the mobile net to try and get as good as we could in order to keep everything in the browser still and not have to rely on big beefy GPUs to run things. And then like Bryan mentioned, out of the box, it can detect multiple people, which is kind of cool and could have some really cool implications for different ways that you could use PoseNet. So let's have some fun with the first toy that we created, face detection and tracking. So here's Will with some really cool glasses on. Bryan, I don't know if you want to step out and show some code here.
So you basically see there we're grabbing that pose. The pose consists of those 17 points that we talked about before. And we're basically going to go into that pose, look at the key points, and say, where's the nose, where's the eyes, and just do some simple math here to determine how wide the glasses are. we'll do a ratio of the image that we're going to be using. We'll do a calculation, so just doing the inverse tangent of looking to calculate the angle of the face so we can apply the glasses in the correct orientation. And then just doing a quick translation based on the nose so we can place them in the correct spot, applying the rotation based on the angle, and then we're just going to draw that image onto the canvas. So what does that look like?
Do you want to talk about how you added some Keypress magic here?
Yeah, sure. So basically what we're doing is we wrapped, oh, there's Andy. We wrapped the PoseNet model in just some React, and basically then we're hooking the keyboard so we can just do some simple logic to say, okay, we now want to render this canvas on top of the video that we're showing. So let's see what we got here.
This harsh light is a little rough, but. So I think we also learned something pretty important about users by coming here and being on this stage. It's super easy as developers to build something in a way that you expect your users to interact with it. So for Bryan and I, sitting in an office, sitting at our desks in our homes.
Nice ambient lighting.
Yeah, the lighting is great. And then you come up here and you've got a white and black background and very harsh light. So I think it's really interesting to understand that your users are going to abuse the things that you give them. And here's just a great example. You got Bob there. Here's another one of the technologies that we used. It's the Canvas API. This is pretty neat. You're able to do basic drawing manipulations just with JavaScript. It's native to all browsers. And there's a bunch of libraries that wrap that make things easier. I guess we did it the hard way, just by manipulating Canvas directly, but there's always a break point where you realize, do I need this additional library? Do I not need it? And I think it's a good practice to try and do things yourself first, insofar as you can still make progress. As soon as you find yourself running into a brick wall and the progress is slowed, it's a great opportunity to bring in some of those other tools. But to begin with, since we had this very simple use case, we decided to use Canvas just directly. A few other things we did here related to Canvas and also related to having access to user media was being able to grab the camera that a user might have available through the media devices and get user media. So there's a few different ways that can be tuned to inspect which devices a user has available to them, whether it's a front-facing or rear-facing camera, what the capabilities of those different media devices are.
Yeah, so once you have those 17 key points, to actually start being able to understand or how to score how those body parts are in relation to something else, we need to turn those into vectors. So just basically taking each one of the 17 key points, iterating through those, creating vectors between an additional key point. And so basically you're creating a bunch of XY vectors in that space that we can then start to say, okay, based on this vector, how is it going to compare to some other vector that you're expecting? And the way we do that is we created basically like a gold standard of a yoga pose. And we said, okay, if we were to look at that yoga pose, what would it look like in XY vector space, and create that model. So that portion is just an algorithm that's running that's saying, let's take a look at that vector, compare it to this other vector, and then use something called cosine similarity that's basically going to determine the angle difference between those two vectors. Once you have that angle, then you know basically how far away you are. If you're at 1, that means it's perfect. Those vectors are completely on top of one another. Or if it's 0, it's going to be basically 90 degrees away from that. And if it's -1, it's going to be 180. So you're basically doing the exact opposite of what you expect.
Oh, and one cool trick here. Anytime you're talking to a data scientist and you've just come up with a manual model, you can still tell them that it was a neural net. You just use your brain for it. So.
So this is basically how we did this. We went through.
Real quick, Brian.
Sure, sure.
This image has nothing to do with this slide. I just wanted to get a picture of Zach Galifianakis on there.
Thanks for the clarification. So we're basically looping through this, and what we're doing is we're appending. So PoseNet gives you the pose. What we're doing is we're just adding some additional information to that pose. So we're going to look at and say, we're going to create this list of vectors. We're just going to give it the part index of one part and the part index of another part, and then basically define what's that. So the right side then is the expected vector. So in this case, we're expecting the left eye and the right eye to just be 1 in the positive of x. And so essentially we're looking for both of your eyeballs are level.
Jump out here and show an example of one of the models.
So if you're familiar with mountain pose, maybe you can demo what a mountain pose.
Bonus points if I don't fall off the stage.
One of the. Yep. Nope. You're good. Just stand there.
Mountain.
Literally, just stand there.
I can climb one. I can't pose one. So.
So this is what mountain pose looks like. We're taking. You'll see every line here. Basically, lines 20 through 30. We're saying, okay, these are the expected vectors of that, and it's actually really simple when you define that. I mean, basically, you're looking for how's that represented, and it's basically it's translation invariant. You're just looking for the direction of that vector. Maybe if we can show, do you mind stepping in front? We can show those points. So what you basically get from PoseNet.
I am not here. Where'd I go? Well, this is the most disappointing thing to happen today. Well, let's go through the slides and then try and resurrect things. Man, what a fraud. These people came for yoga poses.
That's right. Confidence just plummets. Yep. So basically, for all the math people out there, this is the cosine similarity scoring that we're using. Again, it's really just taking a look at those angles of the two vectors, and we go across. So if you have, like in mountain pose, it's going to look across those possible 10 vectors, look at the 1 to negative 1.
Back up.
Oh, it is.
And now it's off. That is cruel. That is cruel. Yeah, all right.
Oh,
come on. So there's our key points.
17 magical key points. Who knows how they showed up.
Well, while things are actually working, why don't we jump through to the
agree.
vectors also?
Okay, so these are the vectors that we're creating. It looks like a mess, but basically we're taking every point and looping through and creating a vector. So if in your pose you want to look across, say, compare the shoulder to your foot, you would have that vector available to you. All right, so I say at this point we need to make Andy do some yoga poses. So we're going to be looking for every pose from 0 to 10, 10 being the best. We'll send him through 5 levels of yoga poses, and let's see how he can do. So first one, Andy, we'll be starting off on mountain pose. Let's click start. Good job. 9 on mountain pose. That's good. Next up will be warrior 1. Hands up. Yep.
Oh, that's poor. I can do better.
You can do better?
Nope, I can't do better.
No. Yoga pose says you can do better. We're going on to warrior 2 now. Oh, that's good. Looking good, Andy, on warrior 2. Don't fall off the stage.
We'll see.
3. Good. Get that back foot up a little bit. Oh,
nope.
Looking good. Looking good. And then chair pose. Oh, nice chair pose. Maybe bring those arms up a little bit more. There you go. Lean forward a little more.
Nope.
Yep, there you go. Nice. All right, 38. So 38's pretty good. Wonder if anybody could beat 38.
Anyone feel like they can beat 38?
Any volunteers?
Hey!
Yeah.
I can do it. All right, so what do I do first? Mountain?
You're good right there. So mountain pose.
the edge.
You ready? All right. Mountain pose. Yes, please watch the edge. And next up will be warrior one. Oh, that's a nice warrior.
I do yoga.
All right, next up, warrior two. Looking good. Andy still might be in the lead somehow. Doesn't make any sense.
It's these pants.
All right, warrior three.
I don't want to fall.
Looking good. And now chair pose, Utkatasana. Looks good. Oh, so closer to 36. Pull 2 more points out of it.
I think she was handicapped
Yeah.
by the black.
Thank you. Thanks, Katie.
Thank you.
Thank you, Katie.
We coded it to make Andy win, by the way.
That's how to boost my self-confidence, man. Don't think I'm so good. Oh, sure. So a few things here about design. You can tell from the slides to the actual application, we tried to embrace the Saved by the Bell theme. Good design is really important for a lot of reasons. It lets a user feel like they can be comfortable interacting with the application. It gives them clear direction and purpose of what they're supposed to be doing. It can convey a mood. You can tell this was not supposed to be an overly serious application that we built. And it adds value. When you look at an application that doesn't have a coherent design, it just doesn't feel as fun to interact with. So because I haven't learned my lesson.
Real quick while Andy brings it up, one of our graphic designers, Ian, did all of our work, so big shout out to Ian.
Yeah, he did a great job.
This is when you ask a developer to build you something.
And of course, the camera won't work. But as you can tell, there's absolutely no design at play here. We had a canvas displaying the image from the camera, and it was not very fun to interact with. Didn't let anyone know what to do. And without that design, you can be quite lost. I'll cut my losses on that. So some potential next steps we might want to take if we chose to be even more serious than we are right now.
We misfixed the camera on this list.
Oh, fixed camera, yeah. Support cameras. So we could improve the model. Obviously, the model that we're using right now, that PoseNet model, is the mobile version. A lot of the parameters are tweaked just to be able to run on a MacBook. Considering the wide array of devices that a user are likely to use, you want to be able to accommodate as many of them as possible. We could up our modeling game of the actual yoga poses by doing some real machine learning with TensorFlow, training models against large sets of images of known good yoga poses and bad ones as well.
Yeah.
Tests are extremely important. Tim this morning gave an amazing talk about test-driven development. Anything that sees a user should absolutely have tests. Like, I could probably rant about that forever. But tests
which
become
we have 0 tests.
none at all, clearly. But the value of tests increased directly with like the cost of making changes in your application. The more costly to a user any change would be, the more valuable having tests against those changes are. And then some optimization, we, again, did absolutely none. And I don't know, adopt the Peloton model and become rich by the New Year's rush. And with that, have a super nice night, San Diego.
Yeah, I know.
Thank you.
Thank you.